to the third power. So we begin. So we take the first term in the binomial here, 6x, and raise it to the power n, which is 3. The other term, minus 5, starts at the power 0. We continue. Now what will happen as the first term, the power, decreases to 2, the other term, minus 5, the power increases. Continuing, 6x reduces to the power 1, and minus 5 increases to the second power, and the final term in the expansion, 6x raised to the power 0, so the 6x power is reducing, and minus 5 is increasing to the third power. So 3, 0, power is now 0, 3, and we can use Pascal's triangle to get the coefficients. So we know Pascal's triangles start at the two inside numbers. Alright, always start and ends with 1. So 1 and 2, 3, 2 and 1, 3. So these are the coefficients in the expansion. 1, 3, 3, 1. So 1, we'll put them in. Now let's try and simplify. So this is 6x raised to the third power. So we put 6 to the power of 3 and also x to the power of 3. Now 6 to the third power, 6 times 6 times 6, that's 216 times x cubed. And of course, any value, non-zero value raised to the power of 0 is 1, so negative 5 raised to the power of 0 is 1. Next term, we have 6 and x raised to the second power. So 6 squared is 36. Multiply that by positive 3. Multiply that by negative 5. We end up with minus 540. And x raised to the power of 2. Next, we have minus 5 raised to the second power. That's minus 5 times itself. That's 25 times positive 6 times positive 3. That's 450. X to the first power, which is same as x. And the final term, we have 6x raised to the power of 0. That's just 1. And we have negative 5 all cubed. That's minus 5 times minus 5 times minus 5. That's minus 125. So that's our expansion. Let's move to part B. So in part B, we are asked to solve an exponential equation. So we are able to raise both, make both bases and either sides same. So we can make both bases be 5. So on the left, we have 5. And distribute the negative outside the bracket. So it's minus 5x minus 8 on the right. Now 25 is same as 5 square. So that's 5 square. And the power here is 2x plus 5. So what we have is 5 minus 5x minus 8. Distribute the 2. So 2 times 2x and 2 times 5. So 2 times 2x, that's 4x. 2 times 5, that's 10. So we have the same base on either side. So we can equate the powers. So minus 5x minus 8 is equal to 4x plus 10. And we can move to solve this equation. So we group the x's. Let's group the x's on the right hand side. So I have 4x. Group minus 5x on the right is positive 5x. We have minus 8. Group positive 10 on the left, we have minus 10. So this is minus 8 minus 10, that's minus 18. 4 and 5, that's 9, so 9x. To solve for x, we divide both sides by 9. So x is equal to minus 18 divided by 9, that's minus 2. So x is equal to minus 2. is our solution. Let's move to B part 2. So in B part 2, we have a log equation to solve here. So let's group the positive one on the right. So it's log x plus log x plus 3. I'll group the negative one on the right. It's now positive 1. So the law of logarithm, so we are logging. So we are adding. So the law of logarithm says if we're adding, you can combine the logs into 1 by taking the product. Alright, so the rule says log A plus log B is equal to log AB. That's one of the laws of logarithm. So we have, this would be like the A, the x plus 3 will be like the B. So combine them by multiplying. So we multiply x times x plus 3. That's actually x squared plus 3x. So x times x is x squared. X times 3 is 3x. It's equal to 1. Now, we're not given a base, but for log log here, we're not seeing a base. So we assume it's base 10. Assume it's base 10. So again, the logarithm, convert into exponent. Take the base, what's in the bracket? X squared plus 3x. And we take the base, raised to the value on the right hand side. So the base raised to the power on the right hand side. So that's 10 raised to the power on the right hand side, which is 1, is equal to whatever is in the bracket. So x squared plus 3x is equal to 10. So we have a quadratic. Let's group all the terms on one side to solve. So x squared plus 3x, group the 10 on the left. It's minus 10. And I'll solve by factorization. Right, so this factors, two numbers that add to give positive 3 and multiply to give negative 10. That's positive 5 and negative 2. So if you expand this, you should get x squared plus 3x minus 10. So to solve, we equate both factors to 0. So we equate both brackets to 0 and solve, which means x equal to minus 5 or x equal to positive 2. Those are our solutions for B part 2. Let's move on to part C. So in part C, we're asked to simplify z1 times z2 in the standard form a plus bi, where a and b are real numbers, and we're told z1 is 3 plus 2i and z2 is 4 minus 5i. So we're asked to simplify z1 times z2. Now z1 is 3 plus 2i, and the complex number z2 is 4 minus 5i. So let's expand. So 3 times 4, that's 12. And 3 times minus 5i, that's minus 15i. Continuing, 2i times 4, that's 8i. And 2i times minus 5i, that's minus 10i squared. So let's group the like terms. So we have 12, and group the I terms in I. They have minus 5i plus 8i. That's minus 7i. And recall that I squared is negative 1. So remember, I is actually root minus 1. So I squared is negative 1. So this is minus 10 times minus 1, which is actually positive 10. So what we have is 12, and this will work, let me just write it, minus 7i plus 10. So 12 plus 10, that's 22, minus 7i, and that's the simplest we can make it. In C part 2, we're asked to represent the complex number from part C1. And remember the complex number we got, it was 22 minus 7i. We're asked to represent it on the axis below, on the Cartesian plane below. So So we're doing an Argand diagram, right? A graphical representation of a complex number, 22 minus zi. So 22 is a real component. So 22. So here's the scale. So 22 is 22 minus 7i we're representing. So it should be down here. Alright, so 22. So here's 20. And of course, so 22 will be right here. And 7 is the imaginary axis, so negative 7. So it's negative 7, 22, so it will be here. This will be the point. And of course, some people just leave it like this. Alright, so this is the point, complex number. So we can draw a straight line using a ruler. So I don't have a ruler. So using a ruler, draw a straight line to connect from the origin to the point. We're going to put an arrow there. So this is a complex number, 22. It's a real component. And the imaginary component was minus 7i. So this is a graphical representation. And again, this line is supposed to be a straight line. Alright, so use a ruler when drawing it. Let's move to question 2. Part A. The function 2x minus r over x plus 1, where x is not equal to minus 1. And we're told r is a constant. We're asked to find the inverse of the function. So we can let y be equal to whatever the function is. That's 2x minus r. 2x minus r over x plus 1. And of course, we can interchange x and y. So we're going to interchange x and y. So we have y, we put x. And where we have x, we replace with y. So 2y minus r over y plus 1. And after interchanging, we solve for y. So let's put the x over 1 here. We can just simply cross multiply. Alright, so if we cross multiply, we'll have 1 times 2y minus r. That's 2y minus r. And x times y plus 1. So it's x times y. Well, let me write it. X times y plus 1. Let's come over here, which will be 2y minus r. X times y, that's xy. And x times 1, that's 1x, which is x. So we need to transpose now for y. So we group the terms in y. So we have 2y. Group net xy on the left is minus xy. And group negative r on the right, it's positive r. So we need to factor out the y to isolate the y. So factor y from the first term, that's 2. And factor y from the second term, we're left with minus. We're left with minus x. Equal x plus r. To solve for y, we divide both sides by what's in the bracket. That's 2 minus x. So y is equal to x plus r over 2 minus x. So whatever you get for y, that's what your inverse function is. So f inverse x is x plus r over 2 minus x. And of course, x cannot be equal to 2. Since if x is equal to 2, you get a denominator of 0, and that's undefined. So that's our solution there. And we're asked now we're told that f inverse 9 is equal to 6. Find the value of r. So f inverse 9 can be found by substituting 9 in the inverse of the function. So we know f inverse x is x plus r over 2 minus x. So if inverse 9, we simply replace x with 9. So f inverse 9 will be 9 plus r over 2 minus 9. And we're told it's equal to 6. So we have 9 plus r. What's 2 minus 9? Negative 7 is equal to 6. So we can put the 6 over 1. Cross multiply like that. So we have, or we simply multiply both sides by minus 7. Either way, we end up with 9 plus r Negative 7 times 6, that's negative 42. And to solve for r, we can subtract 9 from both sides. So r equal to minus 42 minus 9, which means that r is equal to minus 51. Alright, let's move on to question 2, part B, which is a remainder problem, remainder theorem problem. Find the remainder when the polynomial, and we're given the polynomial, is divided by x plus 3. Alright, so to find the remainder, so the remainder r is equal to p of, just change the constant, the sign of the constant, so it's p of minus 3. So we substitute minus 3 for x in all the terms here, all the x terms here. So x cubed, that's minus 3 cubed, minus x squared, that's minus 3 squared, and minus 4x, that's minus 4 times minus 3 plus 4. So minus 3 to the power of 3, that's minus 3 times minus 3 times minus 3, that's minus 27, minus, and negative 3 squared, that's positive 9, so that's minus positive, so that's minus 9, minus 4 times minus 3, that's positive 12, plus 4, and you can just put these in a calculator, and we should get negative 20. Part C, we're asked to find the determinant of the matrix, so I'll be using the cofactor method. So the determinant, we'll call the determinant D. So let me use the values in the top row. So we take the 5 and take the cofactor of 5. You get the cofactor of 5 by just crossing out the row that the 5 is in and the column the 5 is in, and you're left with 4, 7, 3, 9. Alright, so the next value in the top row, that's minus 3, but you change the sign. Alright, so this you keep the sign, change the sign, keep the sign. So we're keeping this, we change the sign of the minus 3, that's positive 3. And the cofactor of positive of this term here, cross out the row, cross out the column, you're left with 1, 7, 2, 9. And then the final term in the top row is negative 2. So we keep the sign. We keep the sign. And the cofactor of negative 2, the cross out the row it's in, cross out the column it's in, and you're left with 1, 4, 2, 3. So that's how we get the cofactor for each value in the top row. Alright, so let's calculate the determinant now. So we have outside 5. In the bracket, just cross multiply and subtract. So 4 times 9, that's 36. Minus 3 times 7, that's 21. Plus 9 times 1, that's 9. Minus 2 times 7, that's 14. Now we have minus 2. 1 times 3, that's 3. Minus 2 times 4, that's 8. And we're finishing out 36, take away 21. That's what? That's 15. And 5 times 15, that's 75. In the other bracket, 9 minus 14, that's minus 5. Multiply by 3, that's minus 15. Other bracket, 3 take away 8, that's minus 5. Times minus 2 outside, that's positive 10. And this should simplify to 12. No. Sorry, 60 plus 10, 70. So the determinant is 70. Question 2, part D. An accountant is offered a 6-year contract with an annual increase. The accountant earned a salary of $48,000 at the end of the second year and $82,944 at the end of the 5th year. If the increase follows a geometric series, calculate the amount of money paid at the end of the first year. So at the end of the first year, we don't know what the amount was. So the first year, would be the first term. Let's call the first term A. At the end of the second year is 48,000. So the second term is 48,000. And so on. So we have a series like that and so on. So it's a geometric series. And for the geometric series, we know that the first term is A, the second term is AR, the third term is AR square, and so on. So the second term is AR, and we are told the second term is 48,000. So we can pair these. So AR is equal to 48,000, where R is the common ratio, of course. And we're also told that at the end of the fifth term, that salary is 82,944. So the fifth term, by the way, so first term A, second term AR, third term AR square, fourth term AR to the power of 4. Fourth term is AR cube. So fifth term, the next term it would be AR to the fourth power. AR to the fourth power. So the fifth term is given as AR to the fourth power, and we are told that it's 82,944. So we don't want to solve now for the A. The amount paid at the end of the first year is what we call A. So let's solve for A. So what we can do is divide through. So we can divide. So we have these two equations. Can solve simultaneously. So we can divide through. So we can just divide through. Alright. So AR to the fourth power divided by AR. A cancel A. R to the fourth power divided by R. That's R cube. Equal to 82,944 divided by 48,000. That's 1.728. So R is the cube root of 1.728, which is 1.2. So R is 1.2. So we can now use that to find A. Now remember that we know that AR is 48,000. And we know R is 1.2, so A times 1.2 equal to 48,000. So to solve for A, we divide both sides by 1.2, which means that A will be equal to 48,000 divided by 1.2, which is 40,000. So the amount paid at the end of the first year is 48,000. So amount paid at the end of the first year is $40,000. And in part C, we are told to find the total salary earned by the accountant at the end of the contract. Now, how long was the contract? So accountant is offered a 6-year contract. So we're to find the amount paid at the end of the contract. We need to find the sum of the first 6 terms, alright? So we're going to find the sum of the first 6 terms. So for this geometric series, the sum of the first n terms is A into 1 minus R to the n over 1 minus R. So we can use that formula. So we find the sum of the first 6 terms. So S6 A, we just found A to be 40,000, so 40,000 into 1, R was 1.2, and N is 6, so we're doing the first 6 terms, right? All over 1 minus R, and R is, again, is 1.2. So we can use our calculator to do this. So the following descriptions contain quantitative or qualitative data. So description: the weight of babies born at the local hospital within the month of December. So weight of babies, that's definitely quantitative. The occupation of the persons who traveled to Carnival last year. Occupation, that's it, definitely qualitative. Occupation wouldn't have a numerical value, right? The number of cars that were written off by an insurance company garage last week, that carries a numerical value. So that's quantitative data. Let's move on to part 3, part B. Event A and event B are such that the probability of A is 1/3, the probability of A given B is 5/7, the probability of B given A is 3/5. Calculate the probabilities, the following probabilities. A intersect B, so we know the conditional probability formula. We know that the probability, let me just write them out, the probability of A given B is equal to the probability of A intersect B divided by the probability of B. We also know that the probability of B given A is equal to the probability of B intersect A, which is the same thing as A intersect B. But this time the denominator now would be the probability of A. So how the conditional probability formula works, whichever one comes after given would be the denominator B, probability of B, A, probability of A in the denominator. So we also find the probability of A intersect B. We can simply just check which of these we have more information for. So we have B given A, we have the probability of A. So we have more information in this one. Let's use a substitution in this one. So probability of B given A, we know is 3/5. Probability of A intersect B, we don't know. That's what we're trying to find. And in the denominator, the probability of A is 1/3. Alright, so we can simply just cross multiply here. So we have 5 times the probability. Well, we can simply just multiply both sides by 1/3. Let's multiply both sides by 1/3, alright? So we're just solving for A intersect B. So multiply the left hand side by 1/3. Let me just write it separate. Just write it separate. The left hand side by 1/3. So 1/3 times 3/5 equal to, and multiply the other side by 1/3. So 1/3 times the other side means 1/3 would cancel itself. So all we are left with is probability of A intersect B. And this is, well, 1/3 times 3/5, of course, is 1/5. So the probability of A intersect B is 1/5. So now we're asked to find the probability of B. So we can, for the probability of B, we use the first formula that we wrote here, this one. So let me just restate it. So the probability of A given B is the probability of A intersect B over the probability of B. So we can do some transposing. Alright, we can do some transposing. Let me just cross multiply here, or simply multiply both sides by the probability of B. What we'll end up with is the probability of B times the probability of A given B equal the probability of A intersect B, and therefore the probability of B, if we divide both sides by A given B, the probability of B is probability of A intersect B divided by the probability of A given B. Simply by dividing both sides by probability of A given B. We end up with that. So we know that the probability of A intersect B as 1/5 divided by the probability of A given B. Now earlier in the question we're given the probability of A given B, which is 5/7. So it's divided by 1/5 divided by A given B, which is 5/7, right? Which is same as 1/5 times our reciprocate and multiply. So that would be 1 times 7 over 5 times 5. So the probability of B is 7 over 25. Let's move on. State whether event A and B are independent. So we can do the multiplication test. So we know that the probability of A times the probability of B, if independent, should be equal to the probability of A intersect B. Now the probability of A was 1/3, and the probability of B was 7 over 25. So 1/3 times 7 over 25, which is equal to 7 over 3 times 25, that's 75. And of course, this is not what the intersection was. Remember, the probability of A intersect B was, what was it? Probability of A intersect B was 1/5. So it's not the same as 1/5. So therefore, A and B are not independent, because if independent, the probability of A times the probability of B would be equal to the probability of A intersect B, and that's not the case. So they are not independent. Part C. A bag contains 4 blue candies and 6 yellow candies. 2 candies are drawn from the bag, one after the other without replacement. Draw a probability tree diagram to represent the scenario above. So we have 4 blue and we have 6 yellow. So now we have 10 candies in the bag. Alright, so the tree diagram. Alright, let's start. So the tree diagram. Let's do our branches. So at the end of the branch we put the possibilities. Alright, so this first draw. And of course we can put the second draw after. So in the first draw we have 2 possible outcomes. So we can get a blue or we can get a yellow. Now on the first draw there are 10 and 4 are blue. So it will be 4 out of 10. 4 out of 10. Probability of getting blue. And for getting yellow was 6 yellow, so it will be 6 out of 10. Now on the second draw, again we have 2 possible outcomes. So again, when we draw the second time, we can get either blue, so we put the possible outcomes at the end here of the branch. Alright. Blue or yellow. Now, for the top branch here, this is the situation where the first draw was a blue candy. Now, if the first draw was a blue candy, you would now have 3 candies left. And remember, the first candy wasn't replaced, so it's now 9. So what you actually have is 3 blue candies from a total of 9. So this is the case again where the first candy was blue, so you still have 6 yellow candies. So the probability of getting yellow on the second draw, if the first one was blue, that's 6 out of 9. On, again, bottom branch here is a case here where the first candy was yellow. Now, if the first candy was a yellow candy, you still have 4 blue. So the probability of blue will be 4 out of 9. Since after the first draw I have 9. And if the first candy was yellow, you will now have 5 yellow candies. And of course, on the second draw it will be 9. Alright, so those are probabilities. And then to get what we put at the end here now, we simply multiply along the branches. So 4 over 10 times 3 over 9, 4 times 3, 12. 9 times 10, 90. 4 over 10 times 6 over 9, 4 times 6, 24. 10 times 9, 90. Down here, 6 over 10 times 4 over 9, 6 times 4, that's 24. 9 times 10, that's 90. 6 over 10 times 5 over 9, 6 times 5 is 30. Remember, when you're multiplying two fractions, numerator by numerator, denominator by denominator. So 10 times 9, 90. And just to be certain, when you add all of these values, you should end up with 1. Alright, so 12 and 24, that's 36. 36 and 24, that's 60, 60 and 30. That's 90 over 90. So 1. So you should have 1. Alright, let's see what we're asked to do now. So the question asks us to use the tree diagram above to determine the probability that the candies are of different colors. So the probability that the candies have different colors would mean that either you have blue and yellow, or you get yellow and blue. Alright? So if the first was blue, the second yellow, so first blue, second yellow, that's a probability of 24 over 90. Or plus, or the first was yellow, and the second was blue, again, that's 24 out of 90. Which is 48 over 90. And that will simplify to, if I divide both by what? Divide both by 6, we can simplify that to 8 over 15, or any answer that's equivalent. In question 4, the data shows the distribution of the times in seconds obtained by 20 runners who participated in a 400-meter open running event. Now we have the data here, and we have an incomplete frequency table showing the recorded times, alright, provided. So complete the table by inserting class boundaries, frequency, and class midpoint, base, and the runner's time. So let me just first write the class boundaries. So the boundaries, the numbers on the left, we subtract 0.5. The numbers on the right, that's the upper limit, we add 0.5. So the first one, subtract 0.5 from 40, that's 39.5. Add 0.5 to 49, that's 49.5. And we'll do the same thing for each of them. Take away 0.5 from 50, that's 49.5. Add 0.5 to 59. Alright, so the lower number, the lower limit, we subtract 0.5. The upper limit, we add 0.5. So these are our class boundaries. The frequency now, let me do the midpoint next. The midpoint, we simply take the average, so we add the upper and the lower and divide by 2. So 40 and 49, that's 89. Divide by 2, and we get what? 44.5. 50 and 59, that's 109. Divide by 2, that's 54.5. 60 and 69, add them, divide by 2, 64.5, and so on. So we add the two numbers and divide by 2. The frequency now, count off the numbers that fall between 40 and 49. So look for the numbers in the 40s. So that's one of them. That's another one. That's another one. So we have 3 between these values, 50 and 59. Let's check for the numbers in the 50s. So we have 1, 2, 3, 4, 5. So we have 5 of them. The numbers in the 60s, that's 1, 2, 3, 4. Number in the 70s, that's 1, 2, 3, 4, 5. That's 5 of them. And the numbers in the 80s would be whatever is left. So that's 1, 2, and 3. So that's all the numbers accounted for, all the times accounted for. Alright, so that's the table completed. 3 marks. Using the table in part A above, calculate the average time the runners took to complete the 400 meter running event. So average, so the mean is sum of fx, and of course because it's group data, we're using the midpoint. So let me just use sum of fx, where x would be the midpoint values, right? Over n, and n is the number of runners. We were told this was how many runners now. What did the question say? Yes, so n will be 20. Alright, if you didn't get n, of course you could add all the frequencies. And if you add all the frequencies, you should get 20. So the denominator there should be 20. Number of runners, alright? And then we multiply for each row, we multiply the f times x and total it. So so the first row, f is 3, so it's 3 times x, the midpoint, that's 44.5. Plus the second row, frequency 5, x is 54.5. Next row, frequency is 4 plus 64 times 64.5 plus next row 5 times x 74.5, right? Or do I have 0.75? So 74.5. 5 times 74.5. And the final row we have frequency 3 times 84.5. Now if we enter this in our calculator, the numerator works out to be 1,290. The denominator is 20. So 1290 divided by 20, that's 64.5. And of course, we talk about time in seconds, so the unit there is seconds, right? 64, average time is 64.5 seconds. And part 3, calculate the standard deviation of the times. So now standard deviation is the square root summation of f times x minus x squared. Well, it doesn't matter since you're squaring, but I'm going to put x minus x bar square, where x bar is the mean. So x minus x bar square over n, or you could put n minus 1. It doesn't matter. Alright, so the mean, this is x bar. Alright, this is x bar, the mean 64.5. So what we'll be doing is we'll subtract the mean from each x value and multiply by the frequency. That's what this is saying. Alright, and divide by n and take the square root. Let's do that. Alright, so I'll make some adjustments to the table. Alright, so I need x minus x bar square for each row. So, alright, so let me create a table for x minus x bar square. So I'm just create a column here. for x minus x bar square. So x minus x bar square. Alright, and how do we find x minus x bar? X here are the x values. X bar is the mean, which was 64.5 seconds. So we're going to subtract 64.5 from each x value and square the result. So for the first x value here, 44.5, if we take away 64.5, we're left with negative 20. You square negative 20, that's positive 400, negative 20 times itself. Second one, you take away 64.5, you're left with 10 or negative 10, depending on which one you put at the front. Either way you square either 10 or negative 10 is 100, right? And then 64.5 take away itself, that's 0. So 0 square is 0. So 74.5 take away 64.5, that's 10. You square 10, you get 100. So x bar, so 684.5 take away x bar. So 84.5 take away 64.5, that's 20. You square 20, you get 400. So that those here are x minus x bar values. Now we also need a column for frequency times x minus x bar. Alright, so frequency times x minus x bar square in each row. So the first row, the frequency is 3. 3 times 400, that's 1200. Second row, frequency is 5. 5 times 100, that's 500. Third row, 4 times 0, that's 0. Next row, 5 times 100, that's 500. And the final row, the frequency is 3. X minus x bar square is 400, so 3 times 400, that's 1200. And if we add all these values in this column, 12 and 5, 17, 17 and 5, that's 2, 2, 2, 2 and 1, 2, that's 3400. So the total of the f times x minus x bar square is 3400. And that's how we interpret this formula here. Alright, this formula here for the standard deviation, the square root, the sum or total for the f times x minus x bar square from the table, that's 3400 divided by n, and n was 20. Alright, so 3400 divided by 20, that's 170, and by this 170 is called the variance, and the standard deviation is the square root of the variance. So the square root of 170 is 13.04. So the standard deviation is 13.04 unit is seconds, right? Part B, in a class of 20 students, 40% purchase lunch from the school canteen. Using an appropriate probability distribution, calculate the expected number of students who purchase lunch from the canteen. So, class, so we have 20 students in the class, and it's 20. And the probability that they purchase lunch would be 40%, or 40 over 100. That's same as 0.4. So this is obviously a binomial distribution. Alright, binomial distribution, since we have a finite amount of students here, and the two outcomes are either they purchase lunch from the canteen or they don't purchase lunch from the canteen. So that's two possible outcomes. So the expectation for this type of distribution, so this is a binomial distribution. I'm just label it. This is a binomial distribution, right? So EX is n times P, n the number of students 20, the probability of buying lunch from the canteen is 0.4, so 20 times 0.4, that's 8, so we expect 8 students to buy lunch from the canteen. Part 2, the probability that 10 students purchase lunch from the canteen. Alright? So let's use x. Of course, let's x, we can define x from up here. X represents number of students who purchase lunch. So number of students who purchase lunch from the canteen. Alright, I should have defined x from up here, but alright, so the probability, we are doing the probability that x is equal to 10. And the probability formula, let me write the formula. So the probability formula is n ck p to the power of k 1 minus p to the power of n minus k. In this case, k is 10. And n, we talk about 20 students, right? So it's 20, choose 10. The probability was 0.4, so 0.4 raised to the power of k, and we talk about 10 students, so k is 10. 1 minus p, so 1 minus 0.4, that's 0.6. N minus k, in this case n is 20, k is 10, so n minus k is 20, take away 10, that's 10. And you can enter this in your calculator, using the NCR button on your calculator, and this should give us 0.11714. Alright, 5 decimal places should be more than enough. Part C, the life in years of a randomly chosen truck battery is normally distributed with a mean of 2 and a standard deviation of 0.4. Determine the probability that the life of a truck battery is less than a year. So obviously it's a normal distribution. Alright, so we can just define x. So let x be life of a truck battery, right? Life of a truck battery. So x is whatever the question is talking about in years. So we have to find the probability that the life of a truck battery is less than a year. So we want the probability that x is less than 1. Alright, so we need to find the z value. Alright, so let's find the z value. So doing the probability, let's find the z value. So z, standardized x minus mu over sigma, where sigma is standard deviation x, less than a year, so we're using a 1. Mu is a mean, and the mean of 2. Standard deviation is 0.4. Alright, so 1 minus 2, that's negative 1, divided by 0.4. So negative 1 divided by 0.4, that's negative 2.5. So we find the probability that z is less than negative 2.5. And we can use our tables for that, and it should give us 0.0062 using the z tables. Alright, next. Question 5. Evaluate the following limit. So we have a limit here as x approaches 3, so we substitute 3 at the top. So 3 squared, that's 9. 3 times 3, that's also 9, minus 18. Replacing x with 3 everywhere. Denominator, that's 3 minus 3. And that's 9 and 9, 18. 18 take away 18, that's 0. 3 minus 3, 0. So this is what we call it indeterminate. So remember, for limits, we don't accept 0 over 0 or infinity over infinity. Alright, so what we can do is, when we have a case like this, indeterminate form, we can rewrite the problem by factorizing both the numerator and the denominator. So the numerator, we can think of factorizing the quadratic. So think of two numbers that add to give positive 3 and multiply to give negative 18. Alright, that's positive 6 and negative 3. So this is x plus 6 into x minus 3 when factorized. That's the numerator. The denominator, x minus 3, or 1 times x minus 3 when factorized. So x minus 3 cancels itself here. So what we have is x plus 6 over 1. So substitute 3 for x. We get 3 plus 6 over 1, which is 9. So the limit as x approaches 3 is 9. For part B, differentiate with respect to x. So this is we can keep it as a quotient rule since it's a function over function. Or if you prefer, you can rewrite it. You can rewrite the function e to the negative, bring up the e, it's actually e to the negative 2x using the laws of indices, ln 2x plus 5. So it can either be treated as a product rule problem or a quotient rule problem since it's a function over function. But this can be written as e to the negative 2x. And if you do it like this, it's now a product rule problem. So let me use a product rule. So differentiation. So f prime x represents the derivative of the function. So differentiate the first function. Alright, this would be like my u, this would be like my v. Differentiate the u. Differentiate the function here. It's minus 2. So I differentiate the power and multiply it to the front here. Right? So differentiate negative 2x, that's negative 2. And for the exponential derivative, the power doesn't change. So this is the first term differentiated. We keep the log term. That's a v. Plus, and then we alternate. This time we're going to keep the e to the negative 2x. And differentiate the log function. Differentiate the log function. We do that by differentiating the bracket. Differentiate 2x plus 5, which is 2, and put it over itself. So differentiate the bracket and put it over itself. Alright? So that's our derivative using the product rule. So alternating, differentiate one function, keep the other, plus alternate, differentiate the other function, that's the log function. We'll get 2 over 2x plus 5. I'll keep the exponential function. Right, let's move on to part C. Type not so clear. Find the partial derivative of the following bivariate function. Alright, so the partial derivative, and we're differentiating with respect to x, which means we're going to treat the terms in y as a constant. So look at this. So we have 5 root x times y. Let me just rewrite the function since you type in not so good. So that's 5. By the way, root x is same as x to the power of a half times y cube plus sine y over x. So we are differentiating with respect to x, which means we're going to treat the y as a constant since we're taking partial derivatives. So we're only differentiating the x term. So we multiply by the x power. So half times 5. That's 5 over 2. And we subtract 1 from the x power. So half minus 1. That's a minus a half. Keep the term in y. So we simply multiply by the x power and subtract 1 from the x power. Plus, and by the way, I should have rewritten sine y over 2x. By the way, sine y over 2x. I'm going to rewrite sine y over 2x as sine. So x to the power of 1 is same thing as you bring it up in the denominator, it's bring it up as x to the power of minus 1 times sine y over 2. So all I did is rewrite the x in the denominator as x to the power of 1. So law of indices, so 1 over x to the n is equal to x to the power of minus n, using the law of indices. And that's what I did there. So bring it up is now x to the power of minus 1. So multiply by the x power. So it's plus. So multiply by the x power is actually minus 1x. And we subtract 1 from the power. So minus 1. That's minus 2. And this white term in y remain as it is. So again, for the first term, multiply by the x power half. Subtract 1 from the x power half. So half minus 1, negative half. Next term, multiply by the x power negative 1 and subtract 1 from the x power. So minus 1, minus 1. And that's all there is to it. In part D, the number of people n infected in T days due to the spread of a virus is given by n with respect to t equal 200t minus 100 root t. Find the rate at which n is increasing when t is equal to 4. So we know n with respect to t is equal to this function, and let's just rewrite the function. And again, what we have is 200t minus 100, and root t is same as t to the power of half. So the rate of change of n is n prime. The derivative of n, again, multiply by the power in t, subtract 1 from the power in t. So 1 times 200, that's 200 times t to the power of 0, which is just 1. So it's 200 times 1, 200. Next, multiply by the t power, then subtract 1 from the t power. So half times 100, that's 50. T, half, subtract 1 from the power, half minus 1, that's a negative half. And we can rewrite this a little bit neater. So this is 200 minus 50. Again, losing the laws of indices, we can put back the t in the denominator. It will be t to the positive half. And t to the positive half is the same as root t. We want the value when t is 4. Alright, so the rate. So we're finding n prime 4. That's our solution. So that's 200 minus 50 divided by root 4. And we know root 4 is 2. So it's 50 divided by 2. So that's 25. So it's 200 minus 25. So that's 200 minus 25, which is 175. Part A, 6 part A. Determine the following indefinite integral using c as a constant of integration. So we have a problem here. So what would be nice to do, we can distribute the cos x, so multiply cos x by each term. So cos x times the terms in the bracket. So cos x times the exponential term. That's cos x times e to the power of sin x. And then cos x times 1, that's cos x. So all we did there, just expand the bracket, multiplying each term inside by cos x. So integrate. Now this is, we use integration by recognition. You recognize that when you differentiate e to the power of sin x, you'll end up with that. So remember, integration is the opposite of differentiation. So by recognition, you should realize that differentiating e to the power of sin x, when you differentiate the exponential function, you differentiate the power, right? Differentiate sin x, you get cos x, multiply to the front, you get what we have above there. Alright? So integral of cos x e to the sin x is simply the integral of e to the sin x, because when you differentiate e to the power of sin x, you'll get what we have above there. And again, integrate cos x, you get sin x, and again, for the same reason, when you differentiate sin x, you should get cos x. And don't forget your plus c, since we don't have any limits. Alright, part. The diagram shows a curve, and we have two curves here. Y equal 3x minus 2 raised to the half. On the line y equal half x plus 2. The curve on the line intersect at the points 2, 2, as we can see here, and 6, 4. Alright, so they intersect at these points. So we're asked to calculate the area of the shaded region enclosed by the curve and the line. So to calculate the area should be pretty straightforward. Let's find the area. So the area, remember, integration gives the area. So the area, yes, to get the area, the area is integral of the 2y function. So we have a function here. So take the difference between the limits. So the area is, put up in the formula, so is y1 minus y2, and the limits, using the x limits, 2 and 6. Alright, by the way, you could also transpose for x and use the y limits 2 and 4. Well, let's use the x limits 2 and 6. So integrating the function y. Alright, so the area, alright, the y limit here, the y function here is the curve 3x minus 2 raised to the power half. So that's 3x minus 2 raised to the power half minus, and the other function is half x plus 1. So minus half x plus 1 dx. This is what we need to find now. Alright, let's integrate the first part. So integrate this linear function. So we're doing the reverse chain rule. So we add 1 to the power, we get 1.5. So add 1 to the power, so we have 3x minus 2, we're integrating this. Alright, we're using the reverse chain rule. Add 1 to the power, we get 1.5. That's the same thing as 3 over 2. And then we're going to divide by the new power now. Divide by 3 over 2. Dividing by 3 over 2 is the same thing as multiplying by, and you reciprocate, right? So dividing by 3 over 2 is same as multiplying by 2 over 3. And with the reverse chain rule, we divide by the constant also of the function inside, the x coefficient, that's positive 3. Not the constant, the x coefficient, which is positive 3. Since when you differentiate 3x minus 2, what you get is 3. Alright? Now we're going to integrate. This is minus half x minus 1. This, in the second bracket, when the exponent is really minus half x minus 1. So integrate minus half x. You add 1 to the power, you get 2 and divide by 2. So it's minus x squared. When you divide by 2, you'll have 2 times 2 at the bottom. Now that's 4. And the integral of minus 1, that's minus 1x. And the reason for that, look at minus 1 as minus x. Minus x to the power 0. Since x to the power 0 is 1. Add 1 to the power, you get 1. Divide by 1. So just minus x. And the limits are 2 and 6 and 2. Larger value up here. So we're now going to formulate 2 brackets. Alright, in the first bracket, we're going to replace x with 6. In the second bracket, we're going to replace x with 2. Let's replace x with 6 now in the first bracket. So in the first bracket, what you have is, well, the denominator here will be 9. 3 times 3, 9. Outside here we have 2. In the bracket now, we have 3 times 6, that's 18. 18 minus 2. 18 minus 2, that's 16. So that's 16 raised to the power of 3 over 2. Minus 6 squared, that's 36, divided by 4. That's 9. Minus 6. In the second bracket, we're replacing x with 2. So again, denominator 3 times 3, that's 9. This time we're replacing x with 2. And we have 2. Well, 2 times, right? 2 times, in the bracket now, we're replacing x with 2. So 3 times 2, 6. 6 take away 2, 4. That's 4 to the power of 3 over 2. Minus 2 squared, which is 4. 4 divided by 4, that's 1. Minus, replace x with 2, so minus 2. Alright, let's try and simplify this now. So again, continuing, let's work with the first bracket. So the first bracket, what we have is 16 raised to the power of 3 over 2. Now, this means that you can use a calculator, or you could take the square root of 16, which is 4, and 4 cubed is 64. Multiply that by 2, That's 128 over 9. Minus 9 minus 6, that's minus 15, right? In the second bracket, x is 4. Well, 4 at the base here, so the 2 here, we take the square root of 2. Square root of 4, sorry, which is 2. 2 cubed is 8. 8 times 2, that's 16. Or I can simply use a calculator. That's 16 over 9. Minus 1 minus 2, that's minus 3. Alright? So this will be, you can just enter everything in a calculator. Alright? In one instance. And we end up with 4 over 9 when it does settle. So 4 over 9 square units. That should be our final answer. Part C, the rate at which the temperature x degrees Celsius of water in a tank drops in T minutes is proportional to x minus 20. Obtain differential equation that may be used to model this situation. So we are told that the rate of change of x with respect to time, that's obviously dx by dt, rate of change of x over time, is proportional. So it's equal to a constant k, alright, times x minus 20. So it's proportional to x minus 20. So it's a constant, and we're told the temperature is falling. So the constant will be a negative value, so negative k. Alright, if it was increasing, the constant will be positive, but since it's falling, it's negative k. Alright, so that's the differential equation we'll be using to model the situation. Now, if the temperature is 80 when T0, solve the equation in C1 there above. So we'll substitute here, remember temperature represented by x, right? So substitute x equal to 80 and t equals 0. If we do that, so what we end up with is, well, I'm making an error of judgment here. So x equal 80, we cannot do that because we don't know what x is. We know dx by dt. Alright, so we know dx by dt, but we do not know what x is. So to get what x is, we have to integrate and get an expression for x. Alright, so let's integrate. But before integrating, we have to separate the variables, separate x from t variables. So, of course, we can't do this just yet because we don't have an expression for x. We only have an expression for dx by dt. So if I put this over 1, alright, I put this over 1 and I cross multiply, I'll get dx equal to, and I can do some expanding here. Let me expand this by cross multiplying. So 1 times dx is negative k x minus 20 times dt. I need all the x variables on one side, so I can divide both sides by x minus 20. Let me divide both sides by x minus 20. These cancel. Alright, so I'm left with dx over x minus 20 equal to negative k times dt. And now I can integrate both sides. On the left with respect to x. Alright, so we have 1, let's put a 1 there. So we have a constant over a linear function. That's integral of that is log. The integral of 1 over x. Remember the integral of 1 over x is log x, right? So the integral of that is ln log x minus 20. And if I should check it, if you should differentiate log x minus 20, you'll actually have 1 over x minus 20. Alright, integrate the constant is a constant times time, respect to time, plus c, of course. And again, now we can substitute x. We know that when x is 80, t is 0. So if we substitute these, so substitute 80 for the x as ln 80 minus 20, that's ln 60, and t is 0. So if t is 0, we just have c. K times 0 is 0, so c is log 60. Alright, so what we really have is ln x minus 20 equal negative kt plus, we just found c to be log 60. Alright, and from the laws of logarithm, well, ln is base e. Alright, so it works. E to whatever is on the right hand side is equal to the terms in the bracket. Alright, so the bracket, what's in the bracket, based on the laws of log, is equal to the base raised to the values on the right hand side. That's negative kt plus log 60. Now, we know that x minus 20, now this is equal to e, using the laws of indices, this is e to the kt, negative kt, times e to the log of 60 degrees. So this, what we have here, can be written as that. Notice laws of indices, same base, you can add the powers once you're multiplying, so we can express it like that. Alright, so this is x minus 20 is equal to e to the negative kt, and e to the log 60 is same as 60. E to the log 60 is same as 60. And again, to solve for x, we can simply add 20 to both sides, or just group the 20 on the right. So that's e to the negative kt. And the times 60, we can put it at the front here, since order doesn't matter. And the group negative 20 on the right, it's positive 20. And that's what we're asked to prove. Yeah, x equal 20 plus 60 to the negative kt. And that's it.